All right, let's talk about something that impacts literally everything you do online. It's called network latency, and it's the secret villain behind your gaming lag, those frozen video calls, and just a whole lot of digital frustration.
You know the feeling, right? You're paying for that super fast, top-tier internet plan, but your online game is unplayable or your work call is just a mess of awkward, frozen faces. Well, chances are, it's not actually your speed that's the problem. It's something else entirely.
At its heart, that's all latency is. It's not about how much data you can cram down the pipe, it's about the delay. It's the time it takes for a single piece of information to travel from your computer to a server and back again. And we measure this in tiny little units of time, milliseconds.
To really get this, think of it like sending a package. Latency is just the total time it takes for that one single package to get from your house to its destination. It doesn't matter if the delivery truck is a massive semi that can hold 1,000 other packages, we're only focused on the travel time for yours.
And that whole package thing, it leads us right into the single biggest point of confusion when we talk about how our internet works. So let's clear this up once and for all. So here's the absolute key takeaway. Latency is the delay. That's the travel time for our one package. Bandwidth is the capacity. That's how big the delivery truck is. You see that ping number when you run a speed test? Yep, that's your latency. And this is exactly why you can have a massive, super wide internet pipe and still have a terrible, laggy experience.
This quote just nails it. Think of your high-bandwidth internet connection as a massive, 8-lane superhighway. It's wide, it's fast, no doubt. But if the server you're trying to reach is on the other side of the planet, well, that's just a really long drive. It's still going to take time to get there, no matter how many lanes you have.
Now, here's where it gets really interesting. That total travel time isn't just one single delay. It's actually made up of 4 smaller, different delays that all add up along the journey. Okay, so let's peel back the layers here. The total latency you feel is a combination of these 4 things: propagation, transmission, processing, and queuing. Each one adds its own little bit of time to your data's trip. First up, propagation delay. This one's all about physics, plain and simple. It's the time it takes for a signal to physically travel through a fiber optic cable or through the air. And since we can't break the speed of light, the biggest factor here is just distance. A request from someone in Nigeria to a server in the US is always going to have a higher delay than a request to a local server in Lagos. It's just a longer road.
Next, we have transmission delay. Okay, let's go back to our package analogy. This is literally the time it takes to get your whole package out the door and load it onto the truck. So, naturally, a bigger package or a smaller doorway is going to make that take longer. In the digital world, that means a huge file or a slow connection will increase this specific delay.
Then there's processing delay. Every single time your data packet hits a router on its journey across the internet, that router has to stop for a microsecond, look at the address on your packet, and figure out the next best step on its route. Think of every router as a little post office sorting hub. Each stop adds a tiny bit of time to the trip.
And finally, there's queuing delay. This is a traffic jam, pure and simple. If a router is already slammed with tons of other data packets, yours has to get in line and wait its turn. This one is the wild card. It can be practically zero on a quiet network, or it can be absolutely massive during peak hours.
So, you put it all together, and there's your full picture. The total lag you actually feel is the sum of that physical travel time, the time it takes to get onto the network, the time it's being sorted at each stop, and the time it spends waiting in traffic jams. Okay, so that's the techie stuff, but who cares, right? Why do these milliseconds actually matter? Well, because they have a massive, very real impact on pretty much everything we love to do online.
Let's start with video calls. If your latency is low, say under 100 milliseconds, the conversation just flows. It feels natural. But as that number creeps up, you start getting those awkward pauses. You start talking over each other. And once you get over 300 milliseconds, forget it. The call becomes a frustrating mess.
Now, for online gaming, the stakes are way higher. In the gaming world, a latency down around 20 milliseconds is the absolute dream. Everything you do feels instant. The game is buttery smooth, totally responsive. You've got a real competitive advantage.
But push that latency up over 200 milliseconds, and you get what every gamer dreads: lag. You click to shoot, but your character doesn't fire for what feels like an eternity. In any fast-paced game, that delay is the difference between an epic win and a frustrating loss. And then you have the insane world of high-frequency financial trading. We're talking about a place where making or losing millions of dollars can come down to microseconds. That's millions of a second. These firms will spend a fortune to physically build their servers right next to the stock exchange's servers, all to shave off the tiniest fraction of a millisecond of travel time.
And as more and more of our lives, our apps, our data, our work move into the cloud, the fight against this delay has become one of the single biggest challenges for software engineers today. So what's usually behind high latency? Well, we already know physical distance is enemy number one. But widespread network congestion acts like a global rush hour. Even your own Wi-Fi can be a problem, with all your devices fighting for airtime. And things like VPNs, which are great for privacy, actually add extra stops, or hops, for your data, which increases both the travel and the processing time.
So, if this lag is such a big deal, how do we fight back? What's being done to reduce it? Well, luckily, engineers have a whole bag of tricks to combat latency.
By far the most powerful weapon is just reducing that physical distance. That's the whole idea behind something called a content delivery network, or CDN. It's a global web of servers that keeps copies of websites and videos closer to where people actually live. It's the magic that lets you stream a high-def movie instantly, because that movie is probably coming from a server in your city, not from halfway across the world. Beyond that, engineers are always working on smarter routing and caching data to make that digital round trip as short as possible.
And finally, it's good to know about latency's two annoying cousins, jitter and packet loss. Jitter is when the delay isn't consistent, it's jumpy, and for a video call, an unpredictable delay can actually feel worse than a high one that's steady. Packet loss is just what it sounds like. Bits of your data get dropped along the way and have to be sent again, which causes its own unique kind of lag. Which leaves us with a final question to think about. For decades, the big tech race was all about more speed, bigger bandwidth. But as our world depends more and more on instant, real-time interaction, maybe the real race now isn't about getting faster, but about conquering delay and getting just a little bit closer to a truly instantaneous connection.